Okay, today what we're going to cover is an introduction to fractions. So the first thing we'll look at in class is just an overall discussion question, and the one I'll pose to students is, if you were to explain what a fraction is to someone who didn't know, what would you say? So we'll go on to then have a listen to different students' explanations. But on to more formally what fractions are. So here's a couple of key points. So the first thing is fractions are a number. Very important to note that a fraction is a number. Now, why is this important to note that? Because many students see a fraction like a half and think that they're actually two numbers. Okay, that's a 1 and that's a 2. Okay, and so that's a real block to actually thinking about a fraction. Is a half is a number on the number line, just like 2 is, just like 5 is, just like 16 is, etc., etc., etc. So these fractions here have a spot on the number line just like any other number that you can think of that's a whole number. The word fraction comes from a Latin word, fangere, I think it is, which means to break into parts. Again, I'm not sure about my pronunciation on that, so any Latin experts out there, you can correct me on that. We write a fraction in this form, a over b. So we say that as a over b, or a on b. Okay. We really don't write fractions like this. So if you've got a line in your working out book, we don't write it on a single line like a half plus 3/8 like that. What I want you to do, girls, is to make sure that you're using two lines to do your fractions work. Okay, so here's our two lines here, and we're going to write a fraction as 1. We put that over symbol there. I'll explain what that is in a sec. And then the other part of the fraction at the bottom there. Okay, so we're going to use two lines. So fractions must be written clearly like this, using two lines. Okay, so what are the different parts? Well, this thing here, A, we call that the numerator. Okay, and so we put the numerator on top of this thing here, which we call the denominator. And separating the numerator and the denominator is this sign here. We call that the vinculum. Okay, so they're the different parts for the denominator, and it's important to be able to use the technical words for it. We don't want to be using the thing at the top or that symbol in the middle of those two. So let's get used to those keywords there. All right, so what do the denominator and numerator mean? Well, the denominator is the name or size of the parts. For example, a game of netball has 4 parts. Okay, so that's what the denominator has, is the number of parts. You can divide a cake perhaps into 12 parts. A pizza might be divided into 6 parts. Okay, so these denominators actually have names. So if we divide a pizza into 6 parts, we call that sixths. If we divide a, what was that one again? I can't remember. A something into 12 parts, a cake into 12 parts, we cut it into twelfths. And a netball game, if we divide it into 4 parts, hopefully you're aware that that is quarters. Interestingly, in America, a game of ice hockey has 3 parts to it, which seems a little bit odd because you would think that it would have an even number of parts, either one half and then another half, or quarters. But yeah, a hockey game is in thirds. The numerator is the number of parts of that name or size that you have. Okay, so thinking about a game of netball, if you played a full game of netball, a game of netball is in 4 parts and you had 4 of those parts, i.e. you played 1 game. You could also have 3 of the 4 parts, so the numerator there is 3, okay, that we have. In that instance, you'd get back in the car and you'd say, I got 3/4 of a game tonight. If you didn't attend training, you might get only 1 part out of the 4, a quarter of the game. So that's what the numerator refers to, is in terms of the number of parts that the fraction is in, it's the number that we have. So this number here, 12 on 13. So what that means, so we say 12 on 13 or 12 over 13. And what it essentially means is that there's 13 equal pieces in the whole, and the operative word there is equal. They're 13 equal parts. And what we have 12 of them. So almost 1, okay? 12 out of 13 is almost 1. It's not equal to 1, okay, but it's almost 1, okay? So again, that's why on the number line, it's important to note that if 1 here is here and 0 is here, 12 out of 13 is going to be somewhere very close to 1. All right, fractions can be more than 1, less than 1, and equal to 1. So we want to do an example of each. So here's a fraction that's worth more than 1. It's 1.5. Okay, 1 3/4, 5 7/8. Okay, we can even write that as an improper fraction. We'll talk about it in a sec, but we can say 25 on 6. Okay, that's more than 1. Okay, they can also be less than 1, and we've explored some of them: 1/2, 1/6, 2 out of 733. Heaps of different examples there, obviously. Let's do one more, 1 out of 1,000. And they can be equal to 1. For example, 1,000 out of 1,000, 10 out of 10, 15 out of 15, okay? So there's heaps of different examples for each of those. A fraction is named or can be called either improper or proper. So a proper fraction is a situation where the numerator is less than the denominator. So a situation might be 2 out of 7. That's called a proper fraction because the numerator, this thing here, is less than the denominator. An example of an improper fraction, we just explored one of them before, is 3 over 2. So what's happened here is the denominator is larger than the numerator. Now, girls, improper manners is not a good thing, but improper fractions are fine, okay? So don't think of that word improper meaning bad, okay? Improper fractions are awesome, okay? In fact, the higher you go with fractions or in mathematics, the more you'll actually use improper fractions over these things here, mixed numbers. So an example of a mixed number will have a whole number part and then a fractional part. So 3 3/5. Okay, so it's going to have that whole number part and then the fraction component. Okay, and again, remembering this is just a number, even though it's got 3, a 3, and a 5, you know, 3 separate numbers. That's just a number on the number line, 3 3/5. Here's 4, here's 3 3/5 would be somewhere around there on the number line. Okay, so speaking of number lines, a fraction is a number and can therefore be placed on a number line. So what we're going to do is place all of these 4/7, 6/7, and 8/7 and 13/7. So here on the number line would be 0/7 or 0. This is 1/7, 2/7, 3/7. So what we can see here, 7/7 is actually just 1 and 0/7 is 0. So what we've got is markings here to represent the values between 0 and 1, or some of the values between 0 and 1, with that one split into 7 separate parts. 4/7 is here. That's that one there. 6/7 is that one. 8/7 is that one. And let's keep going. 9/7, 10/7, 11/7, 12/7, and 13/7 finally is that one there. So those 4 things are just numbers on a number line. Just like if I said put 7, 8, and 15 on a number line, These fractions can go on the number line, and that is just 1 number, 2 number, 3 numbers, and 4 numbers. All right, so on to the work that I need you to do now. So turn to exercise 4A. Have a look at the document that shows you what questions. The questions are split into different groups there. So reminder that depending on your level of confidence will dictate which area of questions you work on. And if you've finished that one, then you go to this one here, which is what fractions do you see in this diagram? So I can see that this yellow shaded part represents 2 parts out of 4, or half of the diagram. That's one example. If you're going to do this question, girls, don't split it further. Okay, so I don't want you to split that further. It's got to be a fraction that you can give me. For example, if this was a cake that I brought into school, my question to you would be, what fractions could you give out to students? Like, could you give someone 5/6 of the cake, for example? Okay, but it's been cut this way already. Like, pretend at home you got a knife or something like that, and you've cut it and brought it into school like this, and this is the only way you can actually give out the pieces of the cake. So what fractions can you make? Okay, so there's your work that you're going to do now.